Fact or fiction? The Pacific Ocean is getting larger due to plate convection. 3, 2, 1, go! Pardon! Next slide, please. Alin!
Explain why.
Okay. The Pacific Ocean is actually getting smaller due to the surrounding tectonic plates are converging and subducting under each other. Next slide, please. The Earth's surface is completely recycled every 200 million years. 3, 2, 1, go! Sir, Ana.
Fiction.
Next slide, please. Alin!
Okay, wait,
Because it's a fact because the Earth's crust is continuously recycled. Ginabalik-balik na siya. Because wala may external na one. External na source of. Next slide, please. Fact or fiction? The Atlantic Ocean is slowly getting wider every year. Down, slow. Down. 3, 2, 1, go. Andre. Fact. Next slide, please. Atlantic Ocean is expanding into the sea floor, spreading across the Atlantic Ridge, where the tectonic plates are pulling apart. Next slide, please. That's the last of it. Now we will go to Rafa for convection.
So our first topic would be convection. What is convection? Convection is a fundamental process on the Earth. It is the transfer of heat through the movement of fluids, primarily fluids and liquids. Gases and liquids. It plays a crucial role in shaping various Earth systems, from atmosphere circulation and ocean currents to the movement of tectonic plates. An example of convection would be when you're boiling hot water in a pot. Convection arises from difference in density with a fluid. When a fluid is heated, its molecules move faster and spread out, becoming less dense. This less dense, warmer fluid rises, while cooler, denser fluid sinks to take its place, creating a continuous cycle known as convection current. So same as when you're boiling a water. Pag nag-boil ka sa water, para siya mag-recycle ang colder na water mo, take place siya sa warmer na water sa ubos. So mo siya, circulate siya.
So, things like recycling or
Recycling the fluids and gases.
okay.
Next is convection in Earth's systems. So first is atmospheric convection. Global circulation. The uneven heating of Earth's surface by the sun drives atmospheric convection, leading to the formation of large-scale circulation patterns. Warm air rises at the equator, cools as it moves towards the poles, and then sinks back down, creating Hadley cells, Ferrel cells, and polar cells. Next is weather systems. Convection is also responsible for the formation of weather patterns, including thunderstorms, tornadoes. Warm, moist air rises, cools, and then condenses to form clouds, which can release precipitation and generate powerful winds. Next is sea and land breezes. The difference in heating rates between land and water creates sea breezes during the day and land breezes at night. Warm air over land rises, creating low pressure, while cooler air over water moves into to fill the void, generating a breeze. Second is oceanic convection. Thermally circulation. Convection in the ocean driven by both temperature and salinity differences, creating thermally circulation. This global circulation pattern transports heat and nutrients around the planet, influencing climate and marine ecosystems. Third is mantle convection. Plate tectonics convection within Earth's mantle, driven by heat from the core and radioactive decay, is the primary force behind plate tectonics. Hot, less dense material rises, while cooler, denser material sinks, creating convection cells that drive the movement of tectonic plates. Another is volcanism and earthquakes. The interaction of tectonic plates and convergent boundaries, where one plate subducts beneath another, which leads to volcanism and earthquakes, or in other words, would create volcanoes and start earthquakes. Next would be plate movements, and Christian will take over.
Okay, so group 1, you're giving the relationship between the convection current and the plate tectonic movement, right? Group 1? Okay, very good. Continue.
So, plate movements, also known as plate tectonics, are the movement of large slabs of the Earth's lithosphere, crust and upper mantle. Over the more fluid asthenosphere, these movements shape the Earth's surface and are responsible for various geological phenomena, including earthquakes, volcanic activity, mountain formation, and oceanic relationships. The movement of tectonic plates is primarily driven by two forces related to the mantle progression.
Okay, can you discuss the presentation illustration for that?
It's like this po, oh, like this.
Okay, so what does it mean? The plate movement or the plate tectonic movement is primarily driven by two forces related to mantle convection. So meaning convection fraction, log 2. So what we can determine by that? Meaning there is opposite forces against each other.
Which separate the two slabs.
Okay. So what's the use of the wrench push on that presentation illustration? Look at that. The wrench push is what? The black hole. What's the use of that between the convection fraction? So ridges meaning the mid-ocean ridge. So it pushes each other. So by this illustration, guys, look at that. They are primarily what? Driven by two forces related to mantle convection. So they are moving each other. They are moving away from each other. So now the ridge push here, the mid-ocean ridge, it pulls like that. Nag-separate po sila. So kani siya, represent siya sa South Pole of the vessel. On the plate. Very good. Okay, continue.
So the interactions between moving plates and the boundaries must major geometrical rules. There are three types, which is divergent, which is the one illustrated in the prior illustration, which shows opposite forces that pull each other's slabs. Convergent, which shows a slab falling onto another plate, and then finally a transform which pulls which slides in which the two slabs slide by each other. And also, hotspots are volcanic regions caused by mantle plumes, upwelling of hot material from deep in the mantle. As plates move over a hotspot, chains of volcanoes are formed. For example, the Hawaiian Islands, as shown in this image.
So next is geological features and phenomena caused by plate movements. Let's move the slide, please. So this is earthquake. Sorry for the inconvenience. This is earthquakes. Most earthquakes occur along the plate boundaries due to the built-up release. For example, kaning a room na ay plate movement sa mag-earthquake na rin. Next slide.
Due to the seismic activity.
Yes.
That's correct. That's correct yan, guys.
Next is volcanism. What is volcanism? Volcanic activity often occurs at convergent boundaries, subduction zone, subot pasabot. Subot pasabot, guys. For example, na ay volcanic activity, so naabit plate movement ana. For example, sa Hawaii, di ba? Naidako kayo nga volcanic activity dito. So, sa naitabo, di ba nagbulag-bulag ang balay. Next is mountain building. This is especially continental especially continental positions lead to the formation of mountain ranges. For example, galing sa ang Mount Himalayas. Himalaya, sinetabo, di ba? Tungod kay nagsigbog ang plate.
Yes.
Right? Mountain, di ba? Wala ang mountain. Ang next ay ocean basins and trenches. Kasi pasabot na yan, kamutan na rin nga, divergent boundaries at twin ocean ridges create new ocean crust, leading to the expansion of ocean basin. Convergent boundaries involving oceanic plates is result in the formation of deep ocean. So, example kaya sa Mariana Trench, good, kanina nasa picture ka na. Next kaya ang continental drift and ang history sa continents. Guys, pwede ko mapasa, please?
Over geological time, movement of tectonic plates has caused continents to shift, merge, and break apart. One of the most significant events in the Earth's history was the formation of the supercontinent Pangea. Around 335 million years ago, Pangea eventually began to break apart about 175 million years ago due to the movement of tectonic plates, leading to the formation of the continents as we know them today.
That's it. Diba? Actually guys, kinsa ganito ang naka-discovers ay nakahimong ani nga theory? Engineer, diba? Unsa ang gibo, diba ang Pangea? Unsa ang explain? Sorry guys, na-discover diyan. Diba? Over 335 million years ago, kaya nag-move ang mga continent. Pero di ba siyang first nga theory kay wala na-reject tungod kay lack of evidence. Pero tungod kay na-explain yung tarong kung sa mga full evidence pa na accept. Next kay ang impact on the continents. Pwede ko pabasa please. Here nga bro.
Over millions of years, the process of convection period, allowing tectonic plates to move or collide to one another, have shaped the distribution and formation of continents. The continents have not always been in their current location, and they continue to move at the rate of a few centimeters per year due to the ongoing process of convection and plate tectonics. This movement will continue to shape the Earth's surface, potentially leading to the formation of new supercontinents in the distant future.
Okay. So, guys, para ma-explain natin ni Claro na yung first question, what is the reason nga nag-impact ay ganong na may mga impact sa continent? Tungod sa? Correct! And ang second reason kay tungod sa plate movement.
Okay, you have to emphasize also the relationship between the current connection to the plate tectonic movement.
Okay, ma'am. Sa current tectonic, ma'am, kaya nga
Okay, let's see.
so, tungod sa convection, ma'am, wala po, bandog gamove ang mga kanang crust, kanang plate, ma'am.
Let's say
Okay. Actually guys, ay dinote ni siya guys na ano siya sa research ba ni Albert Eugene gingon niya nga ang plate tigalutar gid na siya tapos ang nasa yang ubos kay mga kalayo or magma. So since na may magma, di ba, mag-boil. So that's why mag-move with ang plate. Una ang impact sa convection. Oh, meron siyang reshape bitaw ang mga plate. Ang may surface. And guys, this is our explanation about this one. And thank you so much for listening.
okay, again, what are the objectives of our discussion? I have to present it last days. What is number one objective? What is number one objective? Define. Okay, define tectonic plates. Second one, you have to do small group discussion. Okay, number 3, present ko na ako with the slide. Hindi pa kita, wala na. Okay, number 3. What was the number 3? Appreciate the presented idea based on the topic assigned to you by group. Right? Okay, now the group 1 presented here. Have you learned something from the presentation of the group 1? Yes, no. Have you learned something with the presentation of the group 1? Yes, very well said for the group 1 presentation on their topic with the illustration too, right? Okay, now I have to process the topics from the group 1 presented. What is the relationship between the convection current and plate tectonic movement? Okay, based on their presentation, tectonic plates in the planet's fluid molten mantle, diba? In places where the convection current rise up towards the crust surface. So what is the crust? The layer of the earth. Is that the first, second, third layer? The first layer, no? The crust. Okay, so the crust surface, tectonic plates move away from each other in a process known as what? Okay, known as the
We see floor spreading.
very good. Very good kayo. Very good. Christian. That's the correct answer. So the plate tectonic move away from each other in a process known as seafloor spreading. Now, how about the convection current? We have to connect the relationship, right? The convection currents in the Earth's mantle are a key driving force behind the movement of the tectonic plates. Now, mantle is the second layer or first layer? Second layer. What is the third layer of the Earth? The core, right? The first one is the crust, the second is the mantle, and the third one is the core. And the core divided into two, the outer core and inner core. Okay, now, sa convection current, I have to process their report for you to understand it well. Okay? So, the first relationship between convection current to plate tectonic movement is the mantle convection. It was stated here in the reports, right? Okay, the first one, mantle convection, the Earth's mantle which lies beneath the crust is made up of semi-solid rock that can flow slowly over time. So the heat from the Earth's core causes the material in the mantle to heat up. Therefore, it becomes a dense. Ilalabot na na-mention din niya, right? Na-mention earlier that less lang ang dense kung mag-heat up na din ang mantle due to the crust. Okay, so as it moves towards closer to the crust, it cools down, becomes denser, and sink back down. So this cycle of rising and sinking material form of convection current, this is what we call the illustration of mantle convection. So how about the plate tectonic movement? So the plate tectonic movement, which make up the Earth's crust, essentially float lang siya, no? On the semi-fluid mantle beneath the Earth. So the convection currents in the mantle create forces that push or pull the plates in different directions. So what are these different directions? What are different directions? Okay, the first one is what we call the divergent. Second, convergent and transform boundary. So those are the plate movement in different directions. So the current rise, it can create divergent boundaries where plates move apart. So what is the meaning of divergent boundaries? Meaning, so what happened? The plates move apart. Okay, move away each other. Move apart. No, so where the currents sink, it can create convergent boundaries. Now, how about the convergent boundaries? A while ago, the divergent boundaries. Now, we talk about the convergent boundaries. Okay, the plates move towards each other. So what happened? Leading to subduction. Meaning when the plate move and face each other, so what happened to the plate? Usaka na siya, rise up. Then forming is subduction. Nasakan, understand? Subduction zone or mountain formation. And thus the major landforms now started to form. The first one is what we call the mountain formation. Now, how about the other one? The lateral movement of the mantle can also create transform boundaries. Now, the transform boundaries where plates slide past one another. So, how would you describe that? If this is now the plate, so what happened? It slide past each other, either forward, backward, right? So that's how it illustrates the movement in different direction of the plate tectonic movement. Have you understand that?
Yes.
Have you get it?
Yes.
Okay, thank you so much, Group 1. You give much understanding in very significant contents of your presentation. You really give the relationship between the convection current and the plate tectonic movement with the illustrations. Now, for the result of your performance, the content 40%, the integration with technology, is it integrated? Yes, very well, 40%. And the teamwork, how many members of the group 1? How many members?
11.
Is it 11?
2, 4, 6, 8, 10, 9.
Okay, how many members? You have 10 members in a group. They are presented only for how many recorders, presenters here? 3. So, teamwork, 20, total of 100. Okay, group 1, good job. Congratulations for that. So, interactive discussion this afternoon. So I hope you've learned something from the group one and tonight additional information.
Ma'am, si
Do you have questions? Okay, so clear for the group one topic. Okay, very good.
Ay, excuse me, ma'am. Na-event mo.
Okay, so before I go, I want to say goodbye, everybody.
Goodbye and thank you, Teacher Pao. See you around and may God bless you.